Hello, we are team GlassesToC, and here's our video submission for the AEP Challenge for this year's Makeathon 2020. 2022 rather, years blend together. So here we have our fan set up with our rotary encoder here. This checks the various, checks to see if the fan is passing by it to record the number of rotations that the fan goes by. On here we have a reflective strip that you can kind of see going by in this video, and that aids the detector in being able to determine when that full rotation goes by, because it's only on one of the three blades there. We also have our temperature and humidity sensor there connected up to this Arduino Nano that I've got set up. I've also got a bit of a makeshift vibration sensor, since I didn't have an accelerometer on hand to be able to do all that. But here I'll go ahead and show how this information is getting digested and where it's all getting processed here. So it comes from this Arduino Nano, and it gets sent on over to my Raspberry Pi over here, and that is all a serial communication. So I can go ahead and read in all of that data, and it goes ahead and plots these set of graphs. Right here we have our Fourier transform, where we can see the structure vibrations in there. We can see here that we have harmonics right around 300 Hertz as it currently stands. And then if I close this, it brings up these next set of graphs where you can see how the device is counting the number of rotations as it's going along, and you can see any sort of like variations in the slope of this graph to determine where some issues where you might have to look at might be. And then we have our humidity readings, in which the reading rate is faster than the sensor output, so really only look at the top line there. It's about 39% humidity in my room right now. It is a little warm in here, right around the 79 range in my room, so we go ahead and see those temperature readings. And then a very interesting thing we have here is that rotation frequency over time. As that fan started to build up speed, as when it first turned on here is when I recorded these readings, it slowly levels out that reading to determine the rough spinning rate of the fan. We can see here that the rotation rate recorded by my rotary encoder and calculated here is roughly 50 Hertz. And you can see any sort of variations over time if this slope of this line begins to fluctuate as time goes along, rather than slowly exponentially sort of dying off there. Then we can know that there's something going wrong with the tower and have that be something that is addressed. And then switching over to my Pi input here, we can see where all that information is being collected in. We're working currently, had to stop a little bit to record this video, but we were working on getting all this information automatically uploaded to a web server, so we could process that data all in real time, rather than having to take it up in chunks and then process it and then gradually reapply that process. But here we can see our data stream coming in from the Arduino over to the Raspberry Pi, being printed out here, which is then getting sent over to our web server. And that concludes our demonstration. Hope to see you soon.